All right. Yeah. Oh, yeah. I'm just gonna be like showing off this little Tetris Attack demo thing. Nothing too fancy about it. I was gonna show off like some Godot stuff too, but I'm kind of lazy just to go through all the stuff. So maybe I'll just bitch about Godot for a few seconds for a tangent. Godot has like a lot of events signals baked into all of its components, and not only that, the editor isn't really much help because it's nice to see it, but you're dragging something from the left to the right of the screen constantly when you could do it all in code. But to do it in code, you gotta dig into the underlying tree structure that Godot has, which is a bunch of nodes that you can't index to, and you can only access it through a string or a label. So now you're looking at the root of the tree, following it up the tree, checking each individual node until you find what you want. So and all of it is OOP style. So everything inherits off of like a base node that the node takes in. I don't even know what the hell. It has like a very generic thing where it accepts a process, which is basically like a delta time, and then that updates anything unless you directly flag it that oh, it's paused. So don't pass in the delta for a bit. It's very clunky. It's a piece of shit. Fucking sucks. Alright, so this can be a loose tutorial, I guess. Well, originally I was gonna have this as like serialization and function pointers, the two main things you really need in game development, but I'm kind of lazy. And serialization is well, it's important because what you're really doing is reading a lot of you're parsing a lot of data formats. So that'll be like your mesh models, save data. Save data, eccentric. All right, object pools. Nothing too fancy about this. Basically a fixed array that once it gets to the capacity of the array, it just stomps over the first index, which is the zero index. Then you can add in like a boolean just to check like, hey, is the current array active? And if so, then okay, we'll move on to the next one and check. A lot of these like these fancy terms like pooling and whatnot, they're kind of hard to find because they really are just that simple. All right, recursive functions. It's a function that calls itself. It's a lot easier just to think of it like a for loop, a boomer ass for loop. And then and one of the prerequisites for the function arguments would be just pass in an int that keeps track of the number of loops you're going through. So the number of iterations you're going through, and then you increment it by one before you call it. And then once it gets to the end capacity of however many times you want to call that function, don't call the function, you put in the else just to break out of it. Okay, this I'm not even too sure. I just put in virtual tables because, I think they are. I don't know. A lot of times when you see online, people like talk about like virtual tables and all this fancy stuff, and I don't know, dog, it's just like the fucking place in memory that's like a chunk that you're directly looking through. So that'll be like a database and you're peeking into it just to find what you want. But don't be making comparisons that it's like Java or something, because you're not making copies. You're peeking into that chunk of memory and then you're finding the index that you're looking that you want. So you could take it as IDs, or you could just have it as is. And then once you find that memory address, you bring it back to the calling spot that wants it, and then you dereference the pointer to get the value. All right, function pointers. These are the backbone of event-driven programming. Basically, you declare the function. Well, you declare the function signature type, and then you create a spot in memory where it's expecting the pointer address of a function, and then wherever you want to have this asynchronous behavior. I don't know, that sounds way too fancy. Basically, you're hooking up the declaration to a function signature that you're creating elsewhere, and then you're assigning that memory address function to that function's name.